Hello everyone, welcome to my channel. So today's LeetCode daily challenge is robot collision, and as you can see, it is a hard problem, right? So what does the question state? So our question simply there are given two vectors and one string. So two vectors basically there are robots, and each robot contains some position, some health, and direction, which can be left and right. Okay. Now these robots move simultaneously with the same speed, right? And when these robot moves like comes onto the same position, like they collide. Okay. So basically, like the robo is moving in this direction and in this direction at particular when this position becomes equal, then they both collide. Okay. Now the second condition, whenever the collision occurs, what will happen? The lower health robot will be removed from the line, and the one with the greater health will survive, but its health will be decreased by one. Okay. So suppose like they both collides, its value is 10, its value is 13, then this robo will be move out of the line and it becomes 13 minus 1, that is 12. Okay. Hope you have got that. Right. So at the end, what we have to do, our task is to return a vector of all the vector containing the health of all the robots that have survived. Okay. For example, if this robot survives and this robot survives, then we have to send the health of these two robots. Okay. Now, uh, until this, for now, it is not a hard level question, right? Because we simply have to collide and we can simply use stack. So whenever this robo comes and this robo comes, we can compare them and move the values onto the stack post pop condition. Okay, but there is also a position given here, right? So what we have to do is basically if these two robo survives, right? Suppose it is this robo is 2 and this robo is 1, right? So we have to return the health of these two survived robo in this order only. Like we cannot do this in one and two way. Okay. But the problem here is like we cannot solve this particular question without sorting these values, right? So if in order to we in order to solve this problem, we have to sort this, all right? So we have to start from this 1, 2, 3, 4, 5, right? So we have to maintain the order of this indexes, right? So that's what makes this problem a little tricky, and so it comes into the hard part. Now, coming to the point why we cannot solve it, why we have to sort it, why we cannot do in this way only, right? So, like here I have taken one example. So basically, we are given position 20 and 10, health is equal to 90 and 100, and direction is left and right. Okay, so if we do not sort this particular uh, vector, what will happen? 20 position will come here and 10 will come here, like right? And at 28 there is 90, and at 10 there is 100. So basically, this moves in the left direction and this moves in the right direction, right? So they will never collide. So what should be our output? 90 and 100. But actually its output is 99. How? Because the position should be in the sorted order, right? So 10 should come before 20. Okay. So if 10 comes here, 20 comes here, then 100 comes here, and it will be moving in the right direction, right? It comes 20 at 20th position, we have 90, and it moves in the left direction. So they will definitely collide, right? And when they collide, what will happen? 100 is greater than 90, so 90 will be popped out from the line, and this particular becomes 100 minus 1. We will have to decrease it by 1, so it becomes 99. Okay, hope you have got the concept like why we have to sort it. Now, so basically, see, we have to put three things in our mind, right? We have to put the position, health, and direction at the same time in our mind, and we have to also we have to sort it, right? So what we can do, we can take a vector of vector, all right, and inside this vector, I will put position, health, and direction, right? And I will also push this I. What is this I? This I is basically the original position of this these particular values. Okay, because at the end we have to return the vector of the survived health in the position as it was given before only. That's why. At this point, it may be looking tricky, but when we walk through the this question and we will try run this, then it will become more clear. So let's just sort this vector, right? So when we sort it, it becomes sorted according to this position, right? The first value. So basically, what will happen? This will become sorted in this way: 1, 2, 3, 4, 5, right? So in this way, it has become sorted. Now I am taking one stack. Why I am taking this stack? Because we have to do collisions, right? So when we have to collide, we what we will do, we will simply push the values onto the stack when the robots are moving in the right, and whenever any robo comes from the left, then we will compare it. If this robo is containing smaller health, then this will be popped out, and we will push it this particular robot. Otherwise, we will not push this robot. This we will remove it, and we will collide it with this one. Okay. Now we have taken one vector result of n size, right? The n size of these all the vectors and the string as well. And I have taken -1. So basically, what does it contains? It will mark the values of it will mark the values of those particular robots who have survived, and it will contains the health of those particular robots, right? And those who have died, it will be -1 only. Okay, hope you have got it. Now, what we will do, we will traverse through the vector, right? So, what we will do? Firstly, I am destructuring this vector values like I is 0, right? So, current health, current directory, and current index, right? I will store it into these three values, right? And if I will check what that is, if current direction is equal to right? If the robot is moving in the right direction, I will simply put it index into the stack. Why I'm putting it index? Basically, with this index, I can assess all the current health, directory, and index of that particular robot. Okay, that's why, because it is a vector of vector. Okay, and we are traversing through the vector of vector only. Right. So it is moving in the right direction. If we take this example, so I will push I into it. Right. It is not sorted. Suppose it is sorted, then I push 0 into the stack. Right. And after that, we will move to this robo. It is also in the moving in the right direction. So I will push it onto the stack only. Right. Its position, that is one index. Now, when we come to the index number 2, it is not is equal to R. This condition do not satisfy. Okay. So now the our current health, current direction, and real index contains the values of this particular robot. Okay, hope you have got it. So we will be moving in the else part. Is our stack empty? No, these two robots are already there. And is our current health is greater than 0? Yes, because it's having the health of this particular robot. And in the condition it is given that the position and the health is greater than equal to 1. Right? So it's definitely greater than 0. This 0. Okay. So we will come into this particular loop. Okay. Now here basically we have to assess the values of this particular row. So right. So our index contains 1, right? In the stack.top contains the 1 index, right? And I will assess the health, the right moving robot's health, right? So where it is health is at the first index. Okay. Right. So V of 1 of 1. V of 1 contains V of 1 of 1. So 1 contains the health. So basically, our health contains the health of this robot, right? Now I will compare if both the robots' health are same. Like if this is 10, this is 10, then what will happen? I will simply pop out this rows, right? If they both collide, they both dies. So basically, I will remove this particular value from the stack. That is first index from the stack. Okay. And what will be done to this row? Its current health will be become to 0, right? So that we can move out of this while loop. Okay. Now the another condition, if this particular robot's health is greater than this one, then what we will do? Simply, we will mark this robot's health with 0. right? And this current row health, this current row, which is I have taken here, this current row health will be decremented by one. Okay, I have decremented it. Okay, and we won't go to the else part, right? And if when we will go to the else part, when this particular row is having the greater value than this one, okay, then what will happen? We have to remove this particular value, this row from the stack. So stack dot pop out, right? And we have to decrement this row health by one. So current health minus minus. Okay. Hope you have got it. And this process will continue, right? Until when? Right, until this condition satisfies. So basically, if this row dies, then its current health becomes zero. So this condition dissatisfies. And if this dies, then what happens? We will collide this row with this one. And if this also dies, then what will happen? This row will be moving towards the left. Stack becomes empty. So we will be moving out of the stack, right? And when we move out of the stack, then what? This particular robo have survived. Okay, so it has a definitely greater than the zero. So what we will do, the result that vector we have taken for marking the position of the robots that have survived. Okay, so what we will do, at the original position, we will store the current health of this particular robot. So what is the real index? Real index is this. Real index. That is V of I of 3. And I of 3 basically here, right? So it is sorted. Earlier it is like 0, 1, 2, 3. When we have sorted this the position has distorted, but I contains the real position. Okay. So at this particular index, real index, that is V of I of 3, we have stored this current robo health, right? So this robo have survived, and now we will move to this robo. Okay, so hope you have got this. So this will continue until the for loop ends and all the robo basically survives. So, but there is one problem. Stack. What does the value? Suppose this robo dies and this robo dies, then our resultant vector is empty. Okay, because our stack is containing the value of the robo that has survived. So we have to empty this stack. So basically, I will empty this stack, right? And I will contain is index, right? Stack dot top contains the index, like one index is here. I will pop out this one from the here, and now at the original value of this particular robo, right? Original value is stored where? At this, that v of 1 of 3. 3, what is it? 3. At the 3, it contains the exact real value. Okay, sorry, real index. So at this particular index, what we will store? V of in of 1. At 1 there is health, at 3 there is index. Okay. Hope you have got it, right? So what will be the answer? Like if this robo, if we talk about this, so 10 collides, right? So it becomes 0, 15, then 15 and 12 collides. So 15 is greater than 12. So basically 15 becomes 14. Okay. So our vector would look like this: minus 1, 14, and minus 1, right? So here the all the values in the result that contains minus 1 will be removed, and the new vector final will be stored, and we will simply return this final. Okay, now simply dry run. If we dry run this, here I have taken one case, position R3. This is the case that we were talking about the earlier, like this whole tree. Okay, and this is it. Health is given, direction is given. Firstly, we will sort this particular vector. So after sorting, see the position that changed completely. Like 2 was at the 0th index, now it is at the 0th index. Okay, health, and the original position was 2. Okay, so original position was 2, so we have marked here. Okay, now what we will do, we will run a for loop through this. Okay, our stack is currently empty. The stack will contain only the index of this particular vector. All right, and resultant is also minus 1, minus 1, minus 1, minus 1, because there's nothing we have done now. Now if I move through the 0th index, what is the current health? Current health is v of 0 of 1. Okay, v of 0 of 1. We that current direction is r, that is right, and current index is 2, that is our 2. All right, now If the current direction is equal to right, which is true, then we have to insert this particular zeroth index into the stack. Okay, here for better understanding, I have also inserted 15 and R, but in actuality, only zero is inserted. Okay, now we will move to this. The current direction is R only. Okay, so it's true. So basically, we will insert the values into the stack. So 0 and 1 are onto the stack for now. For index I is equal to 2, this particular direction is L. So what we will do, we will move to the else part. And what does the else part contains? Until it will check whether our stack is empty. No, it is not empty. And whether our current value, current health is equal to is greater than 0. Yes, because current health is, what is it? It is 15. Okay. So, I'm sorry, I have done one mistake. Current health is actual is 10. Okay. So what we will do, we will compare this 10 value with this particular 10 value. Okay. We will compare this 10 value with this particular 10 value, and as they both are equal, so what we will do, we will mark this current health with the 0, and we will pop out this. So basically, this condition satisfies. Which one? This condition, current health is equal to the right moving robot's health. Okay, so this is the right moving health robo, and this is the current health. It is 10. By mistake, I have written 15. So basically, what we will do, they both will collide, they both will die. So we will remove it from the stack, and we will mark this current robo's health with 0. All right. So whenever the current health becomes 0, we will move out from the while loop. So we will move out from the while loop, and our new stack is this only, right? And we will move to index number 3. Okay. For index 3, its direction is left only. And so for left, again, we will move to the else part. Else part, we will move to the while loop. Okay. So we will check whether 15 is greater than 2 or not. Okay. So it's definitely it is greater than 2. So then what will happen? It is into the stack. That is the value which is in the stack is greater. So what we will do, we will mark the current health with 0, right? Because this is smaller, this will die for sure, and this will be decremented by 1, right? So our new stack value becomes 14. All right, hope you have got it right. And we will mark the resultant value, okay, sorry, the vector 0 and 1 value with the 14. Okay, now now we will come out of this while loop. Okay, now where we will come, we will come here. So we will check whether in our stack there are some values. Yes, there were some values, that is this one. Okay, so what we will do, we will mark the resultant like the original index. We will mark this value. And what is our original index? Our original index is this particular, okay, 2. So v of 0 of 3, right? V of 0 of 3. 3 is at this particular 0, 1, 2, 3. Okay. And what we will store here? We will store v of 0 of 1. V of 0 of 1. And this is 15, but now it's become 14. Okay. So 14 only. So we resultant of 2 will contain 14. This basically I have done mistake. It will become 14 here. Okay. So what will our result vector contain? -1, -1, 14, and 1. Okay. And what will our final vector contain? 14. And basically we will return this. Hope you have got this problem right. And if I run it, yes, it is working fine. Okay. And if I submit it, yep, it is accepted. All right. So hope you have understood the problem. See you in the next video. Till then, bye.